Welcome to the YouTube channel, and I'm going to start going through the content for the Pure 2 for further maths. So this is the first chapter we're going to be doing, and it's the exponential representation. So we know that a complex number can be written in the form x plus iy, where x and y are real numbers. And then from last year, we know that this can be expressed in the form z is r e to the I theta, where r is the modulus of the complex number and theta is the argument. And so now we want to explore this a bit more. So we start by recalling our Maclaurin series. And so using these definitions, we're going to come up with a new way to represent this complex number. So we start with e to the I theta. And this is just simply by using e to the x Maclaurin series, but substituting I theta in. So we get 1 plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial. And then this goes on for infinity. And so then we can rewrite this as grouping the real and the imaginary terms. So we get 1 minus theta squared over 2 plus theta to the power of 4 over 4, and so on for all the even powers where the sign alternates. And then we're going to add I lot of the imaginary part. So we're just going to factor out this I here, and we're going to have theta minus theta cubed over 3 plus theta to the power of 5 all divided by 5. And again, this goes on and on and on. If we think about, we have cosine theta and sine theta, and we can explore their Maclaurin series now. And so we know that cosine theta is just a series of even powers divided by the factorials with the alternating signs. So we get that the real part of our imaginary number is cosine theta. And this is just purely by comparing the Maclaurin series expansion for both of them. And then if we do the same for sine theta, it turns out that sine theta is just the imaginary part of our complex number. And again, just by comparing Maclaurin series, we see this. So then we eventually come to the conclusion that our complex number can be represented in terms of sine and cosines. So then we see that z in terms of r e to the I theta is now going to be equal to r cosine theta plus r I sine theta, which then when we finally factor that out, we get to r lots of cosine theta plus I sine theta. And we're moving on to the examples, and we have that z is equal to 2 minus 3i, and we want to find the polar form of this complex number. So we know that the modulus is simply the length of the complex number in the Ardan space. So that's just equal to root 13. And then we're gonna draw the Ardan diagram to find what section of the Ardan diagram our complex number lies, because that helps us figure out the argument. So we know that we're gonna go 2 across the x-axis and 3 down the y-axis. So we're gonna be in the second quadrant. So then we know from our rules in Corpuscle 1 that the argument is simply the negative of the arctan of the angle. If the angle is theta that it makes with the axis, as I've labelled here, then the argument is simply just the negative of this angle, arctan of this angle, which in our case is minus arctan 3 over 2. And once you put this in your calculator, you get minus 0.983. So then we can say that our complex number then is root 13 e to the minus 0.983i. And that's it for example 1. That would get you full marks in the exam. Carrying on with example 2 now. We're going to exploit the fact that cosine and sine are odd functions and even functions. So we know that for an odd function, we get f of minus x is minus f of x, and for even functions, f of minus x is f of x. So for cosine, we get that cosine of minus x is cosine x purely because it's a even function. And then for sine of x, we get minus sine x for sine of minus x. So then if we add e to the I theta and e to the minus I theta, we're going to get two lots of cosine theta. So then if we rearrange that, we get that cosine theta is 1/2 of e to the I theta plus e to the minus I theta. It's the end of the complex representation chapter of Core Pure 2. I'll continue to do these videos for the rest of Core Pure 2, so if you consider dropping a subscription, I'd appreciate it. Thank you for watching and have a wonderful day.